and this obviously is at Supercomputing 2009. So welcome, and we'll talk about this, if the clicker works. There we go. First of all, we're going to talk about LSI, who we are. Then we're going to talk about some early adopters of high-performance computing and what drove their need, what they're trying to do. Then we're going to talk about a complete flip side of the coin, which is the enterprise, and where the enterprise comes from when it comes to computing power and what they want to do and where they approach this problem from. Then we're going to talk about the new ground between the high HPC group and the enterprise and see what's really mixing there and what's coming new there. And finally, we're going to look at some emerging storage requirements for what's coming in there and the key takeaways that come from that environment of HPC and enterprise. So LSI, the storage landscape. When you look at who LSI is, we go all the way from the PC through the network switches to the servers to the storage switches into the storage systems. We have silicon or products or systems all the way from LSI products and systems clear down into the silicon on the hard disk drives. A lot of people don't realize how far we're going into the Supercomputing 09, and I'll show you here in another slide just how far LSI goes. So in storage systems, we also look at who we play with and where we are, all the different vendors we're working with, and all our differentiators that we have, such as a time to market, and we don't conflict with the channel either, because we're selling mostly and almost completely through the OEMs in the different ones you see here, from Fujitsu, IBM, SGI, all these other ones. And we also look at the growth opportunities where we're looking at where we can play in the mid-range to the high end, and you can see how big the mid-range is and how much we're playing in that market. In the industry, LSI works with many different industry associations, including the IBTA, obviously. But on all of these, we have either folks on the board or playing or very active in developing standards that affect the high-performance computing and the enterprise computing, for that matter. And if you look at the floor here, as you're walking around, it's going to be hard to walk past a booth that doesn't have some of our equipment in it. And that's why what we say is we are the biggest little booth at Supercomputing 09. And you can see everywhere, literally everywhere. And by the way, when we talked to the guy who made up this slide, he said, I had to take some blocks off because it was just getting too dark. So we're literally everywhere. So now let's talk about it. High performance computing and all the folks mostly here at SC09, where are they coming from? What they want is they want performance over reliability. They also want to get the latest build. It's like, I don't give a dang if you have only tested that for 5 minutes. Would you get me the code now? And that's what they want. They want the maximum performance, they want the latest reliability, and they want state-of-art technology. A lot of the stuff you're seeing here at the show is completely state-of-the-art. They want to do a read, a compute, do a checkpoint, and then restore. They're done. Bam. Thank you. Flip coin. Let's go to the enterprise. On the enterprise, they are looking at reliability, interoperability, and scalability over performance. They like performance, it's okay, but not at the expense of the reliability. If you're going to be running OLTP, which is online transaction processing on Wall Street, and you're running literally $1 million a second across your network, you don't want to lose that. You have to have the reliability. So they are making sure that you have that reliability and the interoperability of their systems over that. They're also looking for the total cost of ownership, because these things are ongoing, maintaining their enterprises. They have to have that TCO, or total cost of ownership, going. They want to have increased number of terabytes per administrator. The amount of storage in the world today is just exploding, and as it's going like this, the administrators keep managing more and more and more data until the point where they get swamped. They need tools to be able to manage that data and do it more effectively. And finally, they're looking for security and confidentiality of customer data. And some of the ways they're doing that is people can walk off of a hard drive, or they can somehow or go away with this data, and they can steal all this information you're hearing about that folks get in trouble with. Well, enterprise really is worried about that, and they play with it and try to get solutions that come your way when it comes to security and confidentiality. So what's this evolution coming along in this high-end market that's coming along? First of all, what's causing it? We have powerful and inexpensive commodity machines. I don't know if you looked at our booth next door here, but they have little $99 nodes that's actually a little compute node. And they cluster together, 16 of them. That's happening, that's coming, that's getting into the commodity realm. You got fast and cheap clustering interconnects coming along, the Linux popularity and standardizations that are coming with it, as well as the clustering and grid support that are coming along from the Linux world. You then have MPI and PVE message passing libraries. All of these libraries are just making clustering and high performance computing and high-end computing simpler and easier to work with, and web technologies. You also get distributed online databases that are coming along that you want to be able to get access to all these databases and make them effectively, you're heading towards a parallel in that way. Pricing pressures, they're coming along. You know, the universities have all these powerful systems going on, but they are having pricing pressures as it goes along. And finally, you have the globalization of the distributed and the distribution of the data center everywhere to make the power and make it simpler. Well, so what happens here? You have the high-performance computing world, you have the enterprise world. And what's happening, and this is out of necessity, is the two are starting to combine. And in that area called high-end computing, we now have some storage habits that are changing. And this is where we're going to look at and where LSI helps fit into this world. So what are the key enterprise features that are desired in HPC? Well, number one, you need to have reliability. And it was speed at all costs. Now it's recovering the data. If we look at availability, we have redundant components. You're seeing RAID 6 show up here all over the place now. As the HPC group want to have that reliability and have the RAID 6. They also want to have some snapshot capability and some virtualization capabilities. And one thing about this is that in the reliability realm is it used to be that the performance was so important that we didn't care about the reliability. But now it's a matter of being able to realize that the reliability is actually saving you time, it's saving you money, it's keeping you up more so you can do your compute and do your compute factors and do it more efficiently. So this evolution, high-end computing features, you're looking at industry-leading raw performance. And this is with LSI storage coming in here and bringing enterprise capabilities into the HPC markets. You're looking at sequential write performance and low power consumption throughout all of these. So now you're getting benefits to your high-performance computing platforms that didn't exist before. You're getting dense enclosures. We have, if you look over in the IBM booth, we have one of our enclosures that shows 60 drives in a 4U enclosure. Pretty impressive. And that's a lot of capacity that can get into your high-performance computing system while it still has the reliability that we've been looking for. We have field replaceable host interface cards from 4 gig fiber channel to 20 gig InfiniBand to 8 gig fiber channel to, before too long, 40 gig InfiniBand. All those are coming along for the interfaces that are available on these dense enclosures. Reliability and availability. You get the and this is, by the way, look at these systems on the floor here and see how many of them have redundant power supplies. There aren't very many of them. These are all where that reliability and availability are coming from, and being able to get the uninterrupted data. And no single point of failure. That's the dual controllers, dual targets. You have dual access to the storage system. That's a big deal in the high performance, to be able to access that in a high reliability mode. Battery backup. You have proactive drive help monitoring. HPC world didn't really care about monitoring those drives before, but in the enterprise, there's a lot of work going on in the background to make sure that system is operational and maintained and works the way it's supposed to be working. We also have the industry-leading random IOP performance. And there's one other interesting thing is we have the ability to add security into these systems by way of data encryption, or full data encryption, for what's going on there. That's, by the way, this is an interesting feature in being able to know that if you do have a hard drive with a lot of secure or a lot of information that you don't want to get out there, people can walk off the drive and it doesn't matter. It's absolutely useless to them because unless they have the key, they don't know how to get that data off of there. Key takeaways for what we're talking about here. We have high-end computing, and we look at it from the holistic point of view on this one, by the way, is we have the compute power. These systems are extremely powerful from the HPC, all the supercomputers right on here, but now they have the reliability, they have the scalability, and the storage that LSI is bringing to you. In the past, storage was an afterthought, and this is a very simple and real event that occurs in the HPC market. Storage, okay, I've got to get it. People used to use the word peripheral. It's not true anymore. Storage is a key component to any system, especially now in the HEC or high-end computing type of market. We look at storage components as being important. You want to do your nuclear simulations or your weather analysis or predictions, or you want to do your financial or portfolio analysis, your trading, or let's even do some plastics aging on those things. Storage is going to be able to maintain that information and keep it there for quite a while as you're adding the high reliability storage to the system. Your computational efficiency, well, storage features are helping accomplish the efficiency. And this is where the new part of the HEC is coming into this is even though now you're getting the reliability and the storage and the high performance computing, you're also now getting efficiency and efficiency not only in the computation but efficiency in the way you're storing the data, and you're also getting the maximum amount of performance that you can out of that system. You've got the mean time between failure, the data availability, the cache mirroring, snapshotting, virtualization. All of these things are being brought into the high-performance computing to make the HEC type of world. Confidentiality, again, the security of those data at rest. It is secure. High-performance storage is a vital system component. And by the way, this is a key statement to note while you're wandering through the store. If you have a fast system but you can't trust the data, you know what? All you have is a fast system. Note that. And by the way, this is my presentation. Thank you very much. And thank you, IPTA, for the opportunity to present.